So, hello students, welcome back. So, this is video number 2. So, in the last class, we discussed about the quantum numbers and we discussed two quantum numbers. One was your azimuthal quantum number, and before that, it was principal quantum number. Okay. So, today we will discuss about the rest of the quantum numbers, and the two quantum numbers that we are left with is means quantum number third. So that is your magnetic quantum number. So this magnetic quantum number is represented with ML. Okay. Now the most important point about the magnetic quantum number is that it tells you the number of orbitals in a given subshell. Okay. So you might be remembering that what I told you in the last class. So let me just recap a bit of it. That you have orbit or shell. Inside the orbit or shell, we have subshell, and inside the subshell we have orbitals, and then we have electrons. Okay, right? So we discussed about the principal quantum number related to orbital and shell, azimuthal quantum number related to subshell, and now this quantum number, magnetic quantum number, is related to orbitals. So means inside the subshell you will have orbitals. Okay. So now if you remember the subshells which I told you, we have S subshell. Okay. Then we have P subshell. Then we have D subshell, and then we have F subshell. Okay. So now the question is that how many orbitals will there be in S subshell? Same thing for P subshell, then for D, and then for F. So how many orbitals you have in a particular subshell can be known with the help of magnetic quantum number. Okay. So we have a very simple formula to know the number of orbitals in a particular subshell. So let me write the formula. So this is minus L to plus L. Okay. And if you remember, for S subshell, in the last video, I told you, video number 1, I told you that for S subshell, the value of L is taken as 0. For P subshell, the value of L is taken as 1. Okay. And for D subshell, the value of L is taken as 2. And for F subshell, the value of L is taken as 3. Okay. So this thing you just need to keep in your mind. So just remember this information. Okay. This we have discussed in the last class. So now take an example. So now I have to find out the number of orbitals in S subshell. Okay. So first you can apply the formula, then you can simply remember it. So there's nothing much to do in this. So for S subshell, so ML will be, so L you know for S subshell, L is 0. So you will simply write minus 0 to plus 0. So it simply means it is 1. So the inference here we got is that S subshell has only one orbital, right? So how we make this orbital? Like this, just a square box, and inside this square box we fill the electrons, one clockwise and another is anti-clockwise. Okay, right? So S subshell will have only one orbital. Now the same thing we're going to do for P subshell. Now take P subshell. Now for P subshell, you know the value of L, and L you know that is azimuthal quantum number. So the value of L is 1. So apply the formula. So ML will be minus L2 plus L. So this will be minus 1, then comes 0, and then comes plus 1. Okay. So now you see here, this minus, this is one orbital, this is second orbital, and this is third orbital. Let me name these orbitals also. So this is Px, this is Py, and this is Pz. So the thing we came to know from here is that P subshell has how many orbitals? 3 orbitals in total. And the name of these 3 orbitals is Px, Ey, and Pz. So how we will make it? So we will make it like this, 3 squares. So these are 3 orbitals, Px, Py, and Pz. So I think this is clear to you. So these are the number of orbitals in P subshell. Okay. Likewise, work out for D subshell. So let's do it for D subshell. So for D subshell, the value of L is 2, right? So now you have to simply apply the formula. So when we will simply apply the formula, so ML will be minus L2 plus L. So this will be minus 2, minus 1, 0, plus 1, plus 2. Okay. So now if you will see here, how many orbitals are there? This is one orbital. This is the second orbital. This is the third orbital. This is the fourth orbital. And this is the fifth orbital. So you will say that D subshell has 5 orbitals. Okay. So we can also name these orbitals. So for HL chemistry, you should know the name. For SL people, the name is not much important. So the name will be, so this is DXY, this is DYZ, this is DZX, this is DX square Y square, and this is DZ square. So how will you make the 5 orbitals? Like this. So these are the 5 orbitals. Okay. Before going further, let me tell you one more thing. So now if you see, this S subshell has only one orbital. So how many number of electrons can it have maximum? So maximum 2 electrons can be filled in S subshell, because S subshell has only one orbital and one orbital can have maximum of 2 electrons. Now if you see the thing for this P subshell, so P subshell can have how many electrons maximum? 6 electrons. Okay, so when you will fill the electrons, so 1, 2, 3, 4, 5 and 6. So there are 3 orbitals. So 3 orbitals means 6 electrons, because one orbital can have maximum of 2 electrons, right? Now likewise, if you see for D subshell, so D subshell has 5 orbitals. So now you know that one orbital can have maximum of 10 electrons. So in D subshell, we can have maximum of 10 electrons. Okay. So how will you fill the electrons? That's very easy. You will fill one by one. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so now you came to know that D subshell will have 5 orbitals and it can have maximum of 10 electrons. So that's why we write the configuration like 3D10, for example. So this 10 stands for maximum number of electrons that can be filled in the D subshell. Okay, right? So this is about D subshell. So now we will come F subshell. So for F subshell, the value of L is 3, right? Very simple. So now we will apply the formula. So formula here will be ML is equals to minus L2 plus L. So this will be minus 3, minus 2, minus 1, 0, plus 1, plus 2, and plus 3. Very easy. So now you see how many total orbitals are there. So let's count. So this is your one orbital, second, this is third, this is 4, this is 5, this is 6, and this is 7. So now you come to know that F subshell can have 7 orbitals. Don't say can. So F subshell have or has 7 orbitals. Right? So how many number of electrons can it have to maximum? So the maximum number of electrons that can be filled in the F subshell, as it has 7 orbitals. So maximum number of electrons that can be filled. So maximum number of electrons that can be filled is how much? 14. Right? Because you have 7 orbitals, and I have already told you that one orbital can have maximum of 2 electrons. So 7 orbitals can have maximum of 14 electrons. Right? So this is about the magnetic quantum number. So magnetic quantum number, just let me recap it. It tells you the number of orbitals in a given subshell. Right? So just write it here. So S subshell can have maximum of 1 orbital. P subshell has how many orbitals? 3 orbitals. I have already explained. D subshell has how many orbitals? 5 orbitals. And F subshell has how many orbitals? 7 orbitals. Okay. So I think this is quite clear to you. No issues with it. Okay. So let's proceed further. So this was about magnetic quantum number. Now the last quantum number that we have to study is spin quantum number. Spin quantum number. Okay. So now about the spin quantum number. So this is the last. So this is the last and fourth quantum number. Now if you see the series, just go with it. Just revise it. If you go with the series shell or orbit, what it has? Subshells. And what subshells have? Orbitals. And what orbitals have? Electrons. So we have already cleared this thing, shell or orbit. We have also cleared subshell. We have also cleared orbitals. What we are left with? Electrons. And about these electrons, the information that you are going to get will be with the help of the spin quantum number. This is represented with ms. Okay. So now the spin of an electron. Now take an example. So if you take s orbital. So this is s orbital. Because you know S subshell can have how many orbitals? Only 1 orbital. So 1 orbital can have maximum of 2 electrons. So now when you will fill the electrons, this is 1 and this is 2. Okay, quantum number. So I told you that. So here take an example. So I am taking an example of s orbital. So s orbital will obviously be in the s subshell. So s subshell will have how many orbital? So s subshell will have s orbital. And it has how many s orbital? One orbital. Okay. So now when I will make the orbital, it can be make it like this. Now I told you that one orbital can have maximum of 2 electrons. So when I will fill the electrons, so these 2 electrons will be with the opposite spin. Means the spin of one electron will be clockwise. So this is represented with plus half, right? And the spin of the other electron will be anti-clockwise. So spin of other electron will be anti-clockwise. So how will it be represented? So it will be represented with minus half. Okay, so that's why whenever you fill the electrons in an orbital, they are always in the opposite directions. So one electron is with the clockwise spin, and to balance it out, the other electron is with anti-clockwise spin. So one is plus half and another is minus half. Okay, so this was the last and the final quantum number, that is spin quantum number. And spin quantum number gives us the information about the electrons, their spin, that one has to be clockwise and the other electron has to be anti-clockwise to balance each other. Okay, so this is the nature's law. So this is how we go about it. Okay, students. So with these two quantum numbers, so in the video number 2, we have completed these two quantum numbers. And with this, we finish the quantum numbers in the chapter structure of atom or atomic structure. So in the next class, we will go with another topic in this chapter. Maybe we will do the above principle that we have to, how we have to write the electronic configuration. So now when we have learned about all the quantum numbers, so now we are in a condition to write electronic configuration of an element. So this electronic configuration of an element is written with the help of a principle that is known as Aufbau principle. Okay, so about this thing we are going to discuss it in the next video, in the next class. So till then, goodbye, take care. If you have any doubts, if you have any queries, you want to ask something, then feel free to chat with me. You have my number, you can WhatsApp me, or you can ask me questions in the comment section. Okay, so goodbye students. See you in the next class. Thanks.